Hello and welcome to video number 4 of Learning Scala with me. Now, in this one we're going to talk about some of the basic types. So I've got up this image from the Scala docs to help us go through it. So what we're seeing here is we've got this super type, any, and that has two subclasses. That has any val and that has any ref. Now any val has 9 subclasses, and these are all the ones you see here: double, float, long, int, short, byte, unit, boolean and char. They're all the same as the ones in Java, except for unit, which we mentioned in the last video is essentially the same as void. You basically use unit as a type and say, you know, this is going to return unit, which means we're not actually going to return anything. And then we have the type nothing, which is a subtype of the any val subclasses. Then over here we have any ref. Now this is what we use to create any of your objects. So when you create a class in Scala, which we'll cover in another video, you are basically creating something that is extending any ref. Similar to in Java, how if you create a new class, you are implicitly extending the object. So when you create a class, what you're doing is you are extending any ref, which in this case is a Java lang object, and you are also extending the any type as well. So there are a few things that any type gives you. For example, things like your hash code and toString methods, which are provided by the any type and provided by the compiler. So let's go have a look at some of the stuff that we can do with these types. So if we come over to a terminal and we can open a REPL. So if we were to look at bytes, for example, or actually let's look at what happens when we create some values. So if I were to say like var x, and we're going to reuse this variable, so we'll make it var as opposed to val, and I were to say 5 and we press enter, what's going to happen is Scarlet is going to say this is an integer. It's going to do the type inference to be in an integer. So you can see here it is saying yes, this is an integer. Now if we were to do the same thing again, but we would say x is equal to 5.6 or 5.5, it's going to infer it to being a double. There we go. It's not going to let us redo that because we've already assigned that to be in an integer. But what we can do is we can create a new one and we can say 5.5. So we can reassign something I forgot to mention. You can reassign x to be another int, but you can't reassign it to be another type. So we'll create a new one. We'll say val y is equal to 5.5. When we press enter here, what's going to happen is it's going to evaluate this and infer this type to be a double and not to be a float. So the question is, how do we end up with, let's say, a float if we're going to have it be inferred by the compiler? And how would we end up with something like a short or maybe a long? So let's create something that's going to be inferred to be a long instead. So if we were to do val L for long, and we did 1 L, and it's typical practice is to do a capital L because the lowercase l can look like a 1. So if we do 1L, that will get inferred to a long and not to an integer. Do a similar thing if we want to get a float and not a double. We could do 5.5, and this time if we append f to the end of it, well, look at that, it actually turns out to be a float instead. Now there are some types that I can't figure out if we can actually get type inference for them. I haven't seen any examples of this. So if we were to look at, say, a byte, we can't get a byte to be inferred. So you could do something like you could do val b is equal to xa, right? And I would expect that to be inferred to be a byte, but it's actually going to get inferred to be an integer. It's going to be inferred to be 10. The same thing is true of shorts. I don't know how to get them to be inferred as a short. There's no way that I've seen to be able to do that. So if we put s at the end, it just doesn't work. So for those, if we did want them, we would have to be explicit about them. So for example, if we were to say var that, we can do the colon and then specifically say what type we want it to be, and we can say it's a byte, and we can do something like I don't know, 100, and that'll be fine. And let's try and do the same thing again, but this time let's go over the max. We'll do 128, so the max is 127 and the min is minus 128. So if we do that there, it's going to say a type mismatch. I'm not sure if this will let us reuse this value now. It may do, it may not. So we'll say 127. There we go. And what happens as well when we create a lot of these primitive types is that Scala has a runtime conversion it does. So in the case of a byte, it gets implicitly converted into a Scala.runtime.rich byte, which gives us a useful set of operations that you don't normally get with primitives. For example, we could use the compare to method. So we could take this byte that we've got here and we could do the compare to, and we could, like, say, compare it to itself, and it should return 0 in this case. There we go, it returns 0 because obviously those two things are the same. But that's the reason we get that is because we have this implicit conversion to a Scala.runtime.rich byte. And just quickly, just so you can see as well, to get a short, we can do the exact same thing we just did, and just do, you know, specify the type being a short and give it a short like that, and that's perfectly fine. So we've covered all those. We've also got a few others to cover. So cars, the way we can just get a car is we can say A and then you use single quotes and do A, very similar to Java, and that will get inferred to a car. Booleans, I mean, there's nothing really to infer. It is either true or false, and as we mentioned last time, there's no implicit conversion from any other type into a Boolean. See the previous video for a better explanation about that. It's similar to JavaScript. So if I was to say var bool, we could say true. There we go, and that's going to be a Boolean. There's nothing really that can be otherwise inferred about that one. And one of the other types from the anyval class, the last one I wanted to talk about here, was the unit. We've mentioned it in the previous video. And like I say, the idea of it is that when we create a method, say do something, right, we can explicitly say that we want it to do nothing, i.e. return nothing. And this is partly because Scala is meant to be a more functional language, so you're better off being more explicit about your return type being nothing. Even though in Java we would say void, in Scala we have the type unit. So we're returning a type that is really nothing. So we're not actually returning anything, but we are. Slightly different way of thinking about things. So if we were to say hello, this will be totally fine. So when we close that off, there we go. How do I duplicate that? I don't know how I just did that. That was not supposed to happen. Okay, I don't know why that's doing that. Try it like that. Oh, that's why. I didn't even read the thing. The reason is that I should have put equals here. Okay, there we go. That's fine, and that works. And we can then call that. We can call do something, and it will just print hello. There we go. So that's where we can use unit. So there's one other thing I wanted to mention about unit, and that is that it's used in a way, and I've sort of mentioned this, to represent a side effect. In the sense that we are trying to think more functionally about things. So when we say unit, we are saying this thing, this function, does something other than just return a value. And also the type unit is basically, we can look at it as just a single thing. So if I was to type in unit here and then create a type, it's basically just this. That's unit. That's all unit is. It's just those brackets like that. There's another type as well that's going to be slightly difficult to talk about because it's the Scala nothing type. And the nothing type doesn't have a value. There is no value that exists for nothing. Really, what nothing is it's a subtype of every type, of all of the types that we have. And really, the only thing it's really used for is to signal that there's something gone wrong. So there's some termination of the program that shouldn't have occurred. So that's really what nothing's for. And then there's another type that I wanted to talk about as well, and that is a Scala null. So recall from that diagram we saw earlier that we've got any ref and we've got any type. Sorry, yes, any ref and any type. What am I on with? Any ref and any val. Null is a subtype of all of the any ref subtypes. So the things that are basically Java objects, or Scala objects in this case. Although they are pretty much Java objects. In fact, any ref is an alias for Java lang.object. So null has a single keyword. It's null, as you may be surprised to learn. So if we were to say test, and we were to say null equals null, that's what we can do there. Now, the thing is that in Scala, the only reason we have null is to provide interoperability with other JVM languages like Java and Kotlin, for example. So the use of null is completely frowned upon. You shouldn't really use it if you're writing Scala code. There are better options, such as option. Oh, that was a terrible joke. So yes, so we can have a look at this now. We can have a look at what options are. Options are, they represent optional values. If you've used Java, I think they came out in Java 8. Optional in Java is basically the way of saying this value that we have here, this object, may have a value and it might not. And option in Scala is pretty much the exact same thing. So if we were to create an example now, in fact, we'll come out of the REPL, we're going to create in a little file just so we can have a goosey gander. If I do main.scala, and we do something like this. So we create a hash map, something we haven't really covered yet, but this is from the Java util library. So if we say, I don't know, map or hmap, we can say new java util.hashmap, and we'll make it have the key, we'll make it have the key, key integer, and we'll also make it have a string, return a string. And then if we were to take, for example, hmap and say put, so this is where we're going to put something into there. We could say 1, and we'll say Shane, like that. And then if we were to try and get something out of the map that isn't there, so for example, we could say something option hmap get, and if we try and get the second element in the list, or the, sorry, not the second element in the map, the element in the map that exists with the key 2, which obviously doesn't exist because at the moment all we've got is key 1. So if we try and get the second one out, or the one that has the key 2, well, nothing's going to come. But we're wrapping this as an option. So what's going to happen is we're going to get an option back. So let's have a quick run of this now. And of course I need to print it because nothing's going to happen. Not found, value for nothing. What the hell? Ah, yes. I see what I've done. I should have done this. And that will be all gravy. So run that. Of course I've got to print something because I didn't bother printing it. So we'll print that. And that will print a nice little none. It doesn't exist. There is no option there. It's totally fine. Okay, and what if we were to do the same thing again, but instead of doing that, we do this? What happens then? There we go. So now it comes back that there is actually a value in there. And what we can see here is that the option is either an instance of none, or it's an instance of some. And there are also methods which we can use on options. So for example, up here, we could say, for example, is empty to check if we actually have a value before we say do anything with this. So we could say is empty like that, run it. Oh, I shouldn't have put the parentheses. Run it again, it will work. Okay, so this says false, it's not empty, which means it has a value, which means we could actually go ahead and do stuff with this. So there was one more thing I wanted to cover, and that was casting. in Scala. Now, this is something where I found, since I've been learning Scala, that the documentation seems to be slightly out of date on. So if we were to take a look, for example, at creating an integer, so we say, file x, it's an int, and we can say 1, 2, 3. Well, if we were to try and convert this to a float, we get a deprecation warning, even though the documentation doesn't mention this. Or we could say val f is a float. So if this is how we can cast stuff, we can say float and then equal to x. It's going to moan about deprecation because there's actually a new method called toFloat now that we can use. So if I was to do this, it's going to say, widening conversion from float to int is deprecated because it loses precision. Write to float instead. So we can do that. But this is something I wanted to sort of show you as well, is that we used to only be able to do conversions one way. So if I was to try and do this, I was trying to say val y, this is an integer, and I was to say that's equal now to the float. It's going to have a float. It's going to have a type mismatch because it won't actually convert it back to an integer. But if we were to use the newer method, and let me just close out the REPL a sec and reopen it. If I was to say val x, we don't even have to tell it to say it's an int because we can just do implicit type conversion, inference. It says it's an integer. If I was to then create val f, make it a float, what we can do, and you might be able to guess this, is we can take x and just say to float, and that will work perfectly well. But we can also now do, if I say val y is equal to integer, and we say that is to int, that will now work. And it shouldn't work, according to the documentation. So these are new ways of doing things. And so yes, this is all I really wanted to talk about in this video. It's getting a little bit long now. So thank you very much for watching. If you have any comments, leave them down below. I'll try and answer them all as usual. Leave a like, subscribe for more, yada, 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 da-da-da-da-da-da. Yes, au revoir, bye-bye. Thank you very much for watching.